Today we'll be showcasing AI observability and root cause analysis on these LLMs. We have 3 dashboards out of the box. This first dashboard is focused on token usage and cost control. We have completion and prompt tokens, along with a total token consumption. From these metrics, we can apply formulas to calculate costs depending on which AI provider you are using. This dashboard also includes a few helpful metrics such as total requests, throughput, and requests per model per minute. This graph allows us to see a high-level view on which models are used the most and how often, which can be factored into cost analysis. Our second tab provides metrics around trust and security, or known as guardrailing. We're able to instrument the API calls that verify LLM interactions, and then visualize them as you can see here. A few important ones to note are toxicity, prevented PII leaks, and filtered topics. The graph on the right here gives a nice view into how often the guardrail is executed per minute. All of these widgets can easily be adjusted to stats, graphs, honeycombs, or other visualizations that make sense for the data. Moving on to our final tab, AI performance. This view gives a clean breakdown of how your models are performing. The first widget on the left here provides a nice overview of how popular each model is in your system. The dashboard includes other widgets which have information on errors to the server, hallucinations, relevance, and some machine-specific metrics. This widget in the bottom right is a great identifier of performance. We can see that the Mistral model is underperforming compared to the others. The response time is almost 3 times the other ones. Let's use Ascent's tracing capabilities to dive in a little deeper. We know that Mistral was underperforming, so we're going to search for that model here. This will populate with the recent traces. Selecting any of these is fine. It's worth noting we can narrow the search down even more with filters, time ranges, and advanced search. We can see some helpful data in the trace such as completion and prompt tokens, model name, but what we care about is the long LM response time here. Let's investigate a little more and see the actual API calls being made. Simply by clicking Find Trace, it'll take us in deeper and give us a better understanding of what's happening on the back end. This is a breakdown of all the API calls made during the call to the model. We can see in total, it takes 1 minute and 14 seconds to complete. By clicking into the main model API call, the span shows it took 54 seconds. We can get more detailed information around tokens used and model name by checking the tags. This can be customized easily when instrumenting to send any metadata you would like. Then we have a few other calls down here that takes only a second or two to run. These are the guardrail API verifications I mentioned earlier, and some post calls to the completions endpoint. If we expand the span, some more detail into what the API call contains is provided. Here are the arguments being passed in the API call. You can see this guardrail call is concerning allowed topics. Some more metadata is provided in the span if we scroll down. Back to the main issue though, if the latency issue was here, we would see the timings be longer than 1 second. So from this trace, we can conclude that the main culprit is the actual performance of the model and not any external services. Between visualizations and tracing to root cause, Ascent gives a nice view into the health and performance of your AI models.